right, welcome to Bell Work Week 8, Day 4. We didn't have an opportunity to go over this question in class because of the jazz band concert, which skibbity doop bop be doop boop boom bam. I have bell work every day. Every day I have bell work. That concert was fantastic. It was just great. So I was glad we had an opportunity to do that, and even better is that we have the opportunity to still view our bell work using this technology. So let's go ahead and get started. Writing and balance a following equation. We have iron 3 sulfate and barium iodide react in a double replacement reaction. You should go back to your notes and review double replacement reaction, but we'll talk a little bit about it here. So if we have iron 3 sulfate, let's go ahead and adjust our pens, make sure that everything is spot on so that you can read my writing if that is possible. And we have iron 3 sulfate, which is going to come out to be Fe2SO4 3. And we get that by making sure our charges are going to equal 0. So if you have iron, which has a 3 plus charge, we know this because it's iron 3, and we have the sulfate ion, which we should know by looking at our polyatomic chart that it's 2 minus. Always put a parenthesis around these when the sum of the charges do not equal 0. Now we're going to show that we need 2 of these iron 3 ions, and we need 3 of the sulfate ions. And you'll notice this gives us 6 plus and 6 minus. And if we add those, it equals 0. So for every one of these, we have to make sure that we meet that condition, that the sum of the charges equals 0 in the compound. Otherwise, this is not going to balance so well for us because we'll have the wrong formula. So the next one is barium iodide. And if you cross the charges on that, barium is 2 plus, iodine is 1 minus. So you're going to need 2 of those to equal the 2 for barium. Now when you have a double replacement reaction, what happens is your cations are going to switch place, but we still have to pay attention to charges. Okay, so we can't just say it's not going to just transfer over here and be Fe with a subscript of 2. No, iron is going to now be with iodide, but iron has a plus 3 charge still, and iodine still has a 1 minus charge. So to balance them out, it's going to be FeI3, and you get that by doing 3 plus I1 minus. And so you would get FeI3, and that's how we do that. And that is going to give us a compound where the charges sum to be 0. And then barium is now going to be with sulfate. Barium has a 2 plus charge, sulfate has a 2 minus charge, so we simply write that as BaSO4. And that's all there is to that. Now we have the unbalanced equation. So now we just need to balance our equation. In balancing our equation, we go to our notes, and our notes say the first thing is to write the equation properly. Check, we've done that. Secondly, we are going to count. So we're going to count each atom, or if you have a double replacement reaction, as we do here, you can keep your polyatomic ions the same. Or actually, anytime you see a polyatomic on one side and then on the other side, you can count it this way. Otherwise, you'd have to separate the sulfur and the oxygen. But it's much easier to do it this way. And as long as you can tell that you have the same ion on both sides of the equation, which you will in a double replacement, you can just keep it together. And then we have iodine. And we just count on both sides. 2, 3, so 2 iron, 3 of the sulfate ions, 1 barium, and then 2 iodine. Over here we have 1 iron, 3 iodine, 1 barium, and 1 sulfate. So as you can see, we're not balanced. So we can start anywhere. And since iron's at the top, I'll start balancing with iron. So we have 2 over here and a 1 over here. We cannot delete or subtract or erase our subscripts, but we can add coefficients. So if we simply add a 2 here, now that means we have 2 iron, but we have 2 times 3 iodine, or 6 iodine. Still not balanced, but we got iron is balanced. So we can now look at the SO4. It's next on the list. So, but really you can go in any order. So here we have 3 sulfate ions. Here we have 1. So we put a coefficient of 3 here. Now we have 3 sulfate ions, and we have 3 barium ions. So that 3 gets distributed to the barium, the 3 gets distributed to the sulfate. The next, let's fix barium. We have 3 on this side and 1 on this side. So let's put a coefficient of 3 here. Put a coefficient of 3 here. Now we have 3 barium and 3 times 2 iodine, or 6 iodine. And as you can see, we have 2, 3, 3, 6, 2, 3, 3, 6. So we have the same number of each ion on both sides, or each atom on both sides. And so we know this is balanced. Also look at the ratio. It's 1 to 3 to 2 to 3. This is a ratio that cannot be reduced. So we know that this is written properly. So we go to the next question. And it says calculate the mass of the reactants and products for the balanced equation. So here we have our reactants, and here we have our products. But we have to have the balanced equation. If we go back to our first one, we have a 1 to 3 to 2 to 3 ratio. So we'll just put a 1 to 3 to 2 to 3 ratio. So we'll consider those coefficients in our calculation. So one way to start this is you're going to take, the number of moles. Let's put number of moles of reactant 1 times molar mass of reactant 1 plus moles of reactant 2 times molar mass of reactant 2, which should equal the moles of product 1 times molar mass of P1 plus moles of P2, or product 2, times the molar mass of product 2. So this is all we're going to be doing in our calculation, is taking the moles times the molar mass. So we have to know the molar mass of iron 3 sulfate, barium iodide, iron 3 iodide, and barium sulfate. So let's go to another page here, and let's calculate molar mass. And the first one we were going to do was F of iron 3 sulfate, right? So when you're doing calculating molar mass, you have to break this up into individual atoms. So here we have iron, sulfur, and oxygen. And we have 2, 3 times 1, or 3 sulfur, and 4 times 3, or 3 times 4 oxygen, which is 12 oxygen. And what we're going to do is we're going to multiply those values times the molar mass of the individual atoms. And so we're going to do some rounding here. For instance, you go to your periodic table and you'll see that iron is actually 55.8. We're going to just, to make it easy, say it's 56. And you're going to see sulfur is 32 point something, we're going to just say that it's 32. And if you look at oxygen, it says it's 15.99. We're going to just say it's 16. And so then we'll multiply to get our values, and we should get like 112 grams per mole. Here you'll get 96 grams per mole. And here you'll get 192 grams per mole. You add all that up, and you should get 400 grams per mole. So if we go back to our other page, the number of moles we have in iron 3 sulfate is 1. So we'll say 1 times 4. Now I'm going to go back here a little bit. We're not going to use a unit. We're going to say 1 mole times 400 grams per mole. All right, and that's reactant 1, or iron 3 sulfate, plus, now let's figure out the molar mass of barium iodide. So barium iodide, BaI2, we have Ba and I. We have 1 and we have 2. And so we go look at our periodic table to find our molar masses. Because barium is not really easily rounded, I'm just going to keep it at 137.33. And you should get 137.33 grams per mole. And iodine could be rounded to 127. And if you take 127 times 2, you should get 254 grams per mole. So we'll add those two values together, and we get 391.33 grams per mole. So I'll go ahead and record that in here. So we have now, pay attention to this, the number of moles that we have as a coefficient is 3. So we're going to say we have 3 moles times our molar mass, which was 391.33. Oops. And so when we do these calculations, what we should get is 1,573.33 grams, and we'll call that of reactant, or of reactants. And that really should be equal to the mass of our products if we're following the law of conservation of mass, and we are if we have a balanced equation. So, but we're going to go ahead and just prove that by doing the same calculation for the products. So in the products we have iron 3 iodide. So if we go to iron 3 iodide, which is FeI3, you have iron and you have iodide. And you have 1 and you have 3 of those. So you go to your periodic table. Whoops. And so iron, we said, had a molar mass of 56. So I'm sorry. Iron has a molar mass, of 56. And iodine has a molar mass of 127. So 56 times 1 is 56. And 127 times 3 is 381, for a total mass of 493 grams per mole. And I'll put units on here, even though you probably can't read them. So the number of moles we have for iron 3 iodide is 2 moles, iron 3 iodide being product 1. So 2 moles times the molar mass of iron 3 iodide, which we said was 493, plus the number of moles of barium sulfate. So times the molar mass of barium sulfate. So we need to figure out the molar mass of barium sulfate, BaSO4. And in barium sulfate, we have barium, sulfur, and oxygen. So we have 1, 1, and 4. So barium has a molar mass of 137.33 grams per mole. Sulfur has a molar mass of 32, or 32 grams per mole. And oxygen has a molar mass of 16, for 64 grams per mole. And if we add all that up, we should get 233.33 grams per mole. So we go back and we add, we say we have 3 moles times 233 grams per mole. Probably should put that here. And when we add that up, we get 1573.33 grams of product. Mass is conserved. Follows the law of conservation of mass. So the idea between the law of conservation of mass is that your mass of your products equals the mass of your reactants. And we see that is true, and it will always be true as long as you have a balanced chemical equation. So thank you for watching. I hope to have some more videos like this to share in the future.